Hello, this is Jonathan Ronald Bartholomew, coming to you with another solve, this time of a different kind of puzzle. It's here, right here. It's a fifth dimensional analog to the Rubik's Cube, although it's not fully 5D. It's domino reduced 5D, meaning it's a 2 by 2 by 2 by 2 by 2 puzzle, but in 5 dimensions, 2 to the power of 5. But in 5 dimensions, if you had this in 5 dimensions instead of 3, which is where it correctly belongs, one axis would only allow 180-degree moves. That's why we call it domino reduced. What that means on this puzzle is these silver stickers and these black stickers can only interchange with each other. They can't interchange with the pinks or the purples or the greens or the blues or the reds. But those colors can interchange with each other. If they can all interchange, then it would be fully 5D, but they can't. So not all orientations in 5D are possible. Like you can't have a black or a gray sticker being on the corner here. That has to be one of the other colors. So, and you can only have 180-degree movements on this axis. Anyway, gosh, I'm trying to do this without breaking the puzzle. Okay, there we go. So right now it's solved. You can hopefully see this is the solved state. This side is all green, ignoring these purple buffer pieces. They're not really part of the solvable part of the puzzle. These are all blues. These are all pinks. These are all purples. Reds are on the outside. Yellows are on the outside. Anyway, inside also is okay. Oranges and whites. So it's solved. So I'm going for a solved cube. I'm going to attempt to mix it up and solve it. Fair warning, a couple of things. This at best, the fastest I can probably be is about 3 hours. So if this ends up getting done here, it's going to be like a 3-hour video. Stickers might come off, and I can replace them. I have the ability to replace them without interrupting the video. It's common enough that I don't want it to interrupt my solve, so I have extra stickers. And okay, let's get started. So it's a little bit of an effort to mix it. So there's a sort of what they call canonical moves. There aren't official canonical moves for this, but there are unofficial ones that people stick to. If you've seen enough videos of people solving this puzzle, I've only seen maybe a handful, but there's definitely moves that are allowed and moves that are not allowed. Let's do a big turn. Broke up that clump of blues and greens. think I'm going to replace the sticker right now. As a matter of fact, this sticker is not doing too well. It's a black sticker. Black stickers are more unusual than silver stickers, usually the ones that aren't behaving correctly. Okay. Placement tool here. It's actually just a tiny scissors, but it's great for what I want to do. I could just give it the okay. Dropped it. Okay. You can place it accurately. Okay. All right, so we said we would call this mixed. So we're calling this a mix. Okay, I'm going to time myself. I'm not using a stack mat or anything. Just going to, we're on the honor system here. We're not trying to prove anything. Okay. I'm sure if you really want to, you can look at the time on the YouTube video and see how long I took. Okay. Axial twists need to be replicated on the opposite tesseract. That's one of the rules. Three and one. Okay. So do a 180-degree move on the long side on that tesseract. Means we need to do some gyros. The bottom tesseract. Okay, wow, 2 minutes, 33 seconds. So that's a PB for me right there. I got the 4D stickers, 5D stickers solved in 2 minutes, 30 seconds. Anyway, all right, let's decide. White, yellow, blue, green looks good. I'll have had red, orange. 1, 2, 3, 4, 5, 6, 7. Well, red, orange is perfect over here. 1, 2, 4, 5, 6, 7, 8, 4, 5, 6. Red, orange is spot on that algorithm. only got 2 on that one. I'm thinking red, orange. Okay, so red, orange. So we're doing a step called OBC, orientation of both cells. It's actually, in this case, it's all 4 cells. Well, it's sort of a slow start here, but we got 4 orange reds. This one we had 8 orange reds on the corners, so that means it's going to be exactly enough to get 8 on the inside, which is actually makes life easier. That's why I picked orange red. Okay. Thought I had this thing set up. For starters, oh no, there are no orange reds on that side. We're struggling here. All right, let's make a command decision. For a second there, I was really stuck. Okay. All right, we did not break the puzzle. We didn't break the solve. This cell came off. I reattached it. This doesn't invalidate the solve. In my opinion. And I'm not looking to get this validated anyway. This is more for, I mean, I'm going to try to do my best to be canonical and do the right moves, but I'm not being too crazy about this being absolutely pitch perfect, 100,000% valid solve. I'm not, if that's what you're looking for, this is the wrong video. I see what we're doing. This is pretty much, at least so far, I think, an accurate canonical solve. I mean, I think definitely I know, knowing the cases you can run into later in the puzzle, I know that you can have a single 2x2x2 cell detach and reattach. One can move on its own is what I'm saying. So if you detach one, you didn't reattach it the same exact way, it would still be solvable. Okay. But I guess technically it breaks the solve. Okay. There we have it. Those are all orange red. Okay, so okay, this is the position that I like. This is the one that leads to completion, right? This is the last step. There's orange and red. OBC is done for the silver tesseract. It's orientation of both cells. Okay, so now I need to do it to this tesseract, black tesseract. Actually, I want it to be this way. No, I want it to be this way. Okay. trying to get orange. Okay, I see. So this guy comes over here. Comes and sits on top of here. Okay, so we got half of the orange reds done on this guy, and then we're doing the other half right now. See, half are done, and we're working on this side. Okay. All right. All right, all orange red on the outside. It's been 18 minutes. I'm going to take a quick break. Excuse me, it'll just be a minute. Okay, so let's proceed from here. Solve the silvers first. Okay. Oh, wow. It's a little overwhelming here. These two blue reds go together. That's purple and white. Purple and yellow. Okay. Okay, we got those blue purples done. Now for the other blue reds. Right here. Okay, that's blue reds, but they're not done correctly. Oh boy. This is frustration. These two are done correctly. These ones need to have pink. Okay. That's blue-red done correctly. Okay, now we need to do blue-orange. Okay, we got 2 pieces done at the beginning. Okay. Keep that there so it doesn't get screwed up by these moves. You know you're riding on the Marrakesh Express. You know you're riding on the Marrakesh Express, taking me to Marrakesh. So the blue-orange was actually on the other side of the tesseract is what was happening. Why I couldn't solve it. And now, of course, it's the hardest case. Well, I'm not going to say the hardest. The most tedious case. You know, we could just do a 180-degree axial twist right here, and that would solve it. But we're now paying attention to orange and green. Blue and green. We're not settling for blue green anymore. Well, or orange red or white yellow. We are actually having to do these correctly now. So okay, we still have to obey the axial twist thing all the way through the solve. We do an axial twist. What the? Okay. Just trying to follow what I'm doing. I know I got that tough case, so I sort of honestly lost track. I see what I was doing. Okay, good. Okay, I was doing the corner reorientation algorithm for one corner being out of whack. Okay. 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 And then finally, this. Go a little fast here, but sticking to valid moves. I don't know why I did that. Blue should have done different color. Anyway, okay, let's do orange green. Now Now I can see I've got 2 orange greens here. Let's see if they're in the right spot. White, pink, yellow, purple. Yes, they are in the right spot. Okay. And oh, I can see both of the other ones are in tough spots. So, for example, this goes here. Okay. But it's okay, so what do we want to do? Tricky case, orange, green. Tricky case. Back with another one of those block rockin' beats. I don't know. Just 2 along this axis, I guess. I don't know. This is so out of sorts. Okay. I think if I do this way. Orange green's real tough. It's just give me a lot of trouble. It's just not. Okay, let's try this. No, that's not gonna work. Let's take the canonical moves. Okay. Got thrown off by that sticker matching. Got thrown off into thinking this was the right. Oh man, I'm getting frustrated by this orange green. I just want to throw this thing. I don't know what to do with orange or green. Okay. It's holiday to remove it. All right, let's pick a different face. We could do red-green. We haven't made any progress on orange-green, so, I mean, might as well do red-green. It's not like we'll be losing any progress. Some pesky buffer pieces. Wow, these pieces just don't want to cooperate. You know, Okay. Let's go this way. Wow, all these moves are wearing down these stickers and just taking up precious time. Your precious time, my precious time. Should be 2 orange reds. Yes. Oh boy, it's the first ray of sunshine in about 5 minutes. Okay. Now we're gonna do take a step back. We're at 36 minutes, 43 seconds. We completed OBC. We've completed one Tesseract, and we're working on our second one. Okay, so that's green, red. Okay. Well, let's see if we put this here. Yes. Yes. Okay, it's green light. Sometimes things do work out. Love will tear us apart again. Love will tear us apart again. Is that Joy Division? I can't remember. On the vinyl, ages ago. Love will tear us apart again. Okay, so let's just do this brute force. This goes 180 degrees this way. I'm just These guys are giving me problems. Okay, we've got good parity. Okay, we've got an H case, folks. An H case. R2, U2, R, U2, R2. Okay. Okay. And we have one here that is axial twist away from being solved. I don't know what to do about that. Oh, I see why this is. This, okay, good. That's actually good news. All right. So we need to do, we want this axial twist here. Okay. Now we've got solved guy on the bottom. Okay, and this guy we want to go up direction. So we put that in back. And then it goes in the up direction. So that's this algorithm. R prime U, R prime D2, R U prime, R prime D2, R2. Okay. Let's hope we can get this done right. R prime. U. R prime. D2. R. U prime. R prime. D2, R2. Okay. I think I might have missed an axial twist in there, but I'm not gonna. This solve isn't too strict, folks. This isn't a perfect solve, but we did not end up with parity, so we didn't have to cheat on parity. So this is more or less a legit solve. I missed a few axial twists, and I know I had that piece get detached. But by the way, an axial twist is still a valid position. A single axial twist. I know it has to affect the other tesseract, but it's actually a reachable position, I think. Just like one cell being off is reachable, therefore an axial twist is reachable. It's not a valid move to do an axial twist without doing something on the opposite side, but it is a reachable move. It's a reachable state. It wouldn't be trivial to reach it. All right, it's the 48-minute mark. I'm halfway done. The second half is much harder because it's all gyros. You can't mess up the bottom, so I'm going to take another break, and I think I'm going to have another bang. this soda as my solving fuel. So I haven't actually gotten this far on a video yet because I keep getting bad parity conditions, and this time I got lucky. So I'm thinking this might end up being a complete solve. Okay. Now for the third 2x2. Okay. Just doing a 180-degree rotation. Okay. Might as well get that correct. Okay, so we did those two pieces, but they're not correctly. Oh no, we did these two. And they are not correct. So we're gonna have to do that again. Let's see something real quick. Okay, I was just cheating a little bit. Not doing anything that is illegal moves, but I was just cheating to see the effect that move would have before I committed to it. Okay. Not actually cheating. Okay. So that's orange-white is beginning to form. And we're going to have to be able to do axial twists, so. No, that's not even the right piece. what to do now. Is that correct? No, that's not correct. Is that correct? Yes, that would be correct. Okay, we're just going to have to get these guys. We're going to have to allow one axis. See what I want to do. I'm trying to get these guys so that I can do this axial move back. This gets real tricky, folks. When you get to the second tesseract, what I'm trying to avoid, I can tell you what I'm trying to avoid. I'm trying to avoid, at least for the third 2x2x2, which is what I'm working on right now. Right, I've got two 2x2x2s done right here. What I'm attempting to avoid is what's going to be inevitably the case. I'm attempting to put it off as long as I can. What I'm talking about is all gyros, okay? Eventually it's going to come to a point where every single move is a gyro, and then another gyro. On the last cell, the last 2x2x2 cell, that's how it has to be. However, the third 2x2x2 cell is kind of in between. Oh, I just had a sticker come off. Okay. Okay. Temporary trip to the Cube Hospital. Okay. Okay. See, that's what I get for running my mouth too much. Karma. Let's try out the replacement tool. Okay. Okay. Have to remember to be humble. Mathematics is taking us on a journey here. So I've done two 2x2x2s and then half of a 2x2x2. Now we're trying to do the other half. So the other half is orange, yellow. And I think, how about this move? Is that correct? No, that's not correct, actually. But there are orange yellows over here. Oh yeah, there's two of them. Okay. This has gotten orange yellow, so let's do it this way. Okay. Okay. I had to put that back. That was getting out of control. Okay, so see, we're back to having oranges here. We want to have reds, so we're gonna try to do this in a way that okay, this works. So this guy, gyro that back. Okay. Okay. Okie dokie. Now, all right, we're finally at this stage. I think at this point, it's all gyros. Because orange, I know I'm making invalid moves. I gotta stop that pronto. If I can't do these. Okay. Yeah, it has to be orange yellow. Okay. It's time for final layer algorithms. So I need to get some certain things here situated. Algorithm twist. Okay. All right, we're in the tedious part of the solve. Okay, we've got 12 pieces left to solve, and they're going to be gyros. So orange, white is done correctly. We need to do orange, yellow correctly. Okay. We're going to do a 180-degree move. And gyro out. Kept that intact. Okay. 180-degree move. Out, gyro. Orange, yellow. Okay, we're doing counterclockwise. It's frustrating. 180 degrees. Out. What I'm trying to do in gyro. I know exactly what I'm trying to do. I'm trying to get the orange and yellows all done, but they are so disheveled. How about this? A 180-degree move. Out. Gyro. In 180 degrees. Okay. And then in gyro out. Basically makes it a different type of gyro when you're adding a move before it and after it. You're doing a different kind of puppy. Okay. Okay. Okay, I can see what I need to do. I need to do a 180-degree move on that face. All right. Out. Gyro. In 180 degrees. So I do one move at a time without screwing anything up. Okay. Okay, 180 degrees. After a sip of water. Okay. That worked. Okay. Now, blue, purple. This guy's blue, purple. This guy wants to go here. Okay. Out. Gyro. In. Okay, so we do this 180 degrees. We thought it out. We said it. Gyro. Out. Clockwise? I don't know. This is tricky. Out. Clockwise, we see what we do. Okay. This needs to go here. Make that happen. You need to go clockwise on this axis. This is going to take a long time, folks. See, that was correct. So we do this, get this here. Yes, okay, so we want to go counterclockwise. There's a light at the end of the tunnel. Thank heavens for that. So we want to go counterclockwise. Let's just verify that real quick. To get that guy there. Yeah. Okay, counterclockwise. Out. Gyro. In. Counterclockwise. In. Gyro. Out. Okay. Because see, the thing is now we can do 180 degrees this axis. 180 degrees on this axis. All right, out, gyro, Placement tool. Okay, we're in the middle of an algorithm. I think this was clockwise. I'm not positive. All things being equal, it's most likely gyro. Out. Okay. Okay. Now we want to go. Oh no. No. Before we go clockwise, we need to do this twice. Okay. Good find, Jonathan. Okay. We want to do this 100 degrees on this axis. So that would have put us in a bind if we had actually made that move. As tempting as it was. Out. Gyro. In. We said 180 degrees, I believe. Hopefully we put that the right way, otherwise we just screwed up the cube. Okay. Gimme the man after midnight. Oh no. Well, seems like a rough case was inevitable because this is now, it's out of the way, but it's twisted 180 degrees. Okay, so anyway, it is what it is. Actually, no, we can't put that there. If we do that, we're gonna be back to that other case. Okay. It is what it is. So, clockwise. Okay, and now a double move. Starting to not need this paper. Okay. Counterclockwise. Now, if we just do this guy, see, we have to get this guy out of the way. Clockwise. see what that bought us. So now, yes. Okay, clockwise. Clockwise. Out. Gyro. In. Clockwise. In. Gyro. Out. Okay. Two. Out. Gyro. In. Two, meaning 180 degrees. R2. In. Gyro. Out. We're only a few moves away from having the third tesseract solved. And then it'll be the last tesseract, and then I hate to tell you this, folks, but the cube's solved after that. So I don't know what I can get this solved. Okay. I mean, I'm Buddhist, so I would say, well, it just seems insincere. I'll chant on my own. Okay, we need to do counterclockwise. I need a quick break, folks. Sorry about that. Okay, so we do clockwise, counterclockwise. And then we need to do counterclockwise again. Clockwise. Okay. So that's That's 3 out of 4 tesseracts solved. Let's see. Well, I'm not sure how worried I should be about this axial twist over here. I'm thinking if I do this side, it's also going to be a twist and it's going to cancel itself out. But then it'll twist that side, so I don't know, honestly, what to do about the twist. What we can try to do something like this. Okay. It's going to be a little bit of work, but yeah, this will work. Okay, that works. We didn't make any illegal moves to accomplish that, so let's... Okay, there, we successfully navigated that axial twist. Without doing illegal moves. Okay. Cool beans. All right, that's 3 out of 4 2x2x2s, and we have the last one to go. I think I'll do one algorithm before I grab myself a soda. We're going to do 100 just to get things rocking and rolling. All right, so we're going to do a 180-degree move. Out. Gyro. In. I said this would be 180 degrees. In. Gyro. Out. Okay. We successfully made that move. I see it's a tricky case. Big surprise there, right? All right. All right. Okay. So I don't feel too bad about taking 1 hour and 34 minutes to do the first three 2x2x2s. 3/4 of the puzzle. Okay. We gotta go counterclockwise. Okay. Now what were we doing? I can see. Okay. I can see what we were up to. There's that. But this guy's in the way. This guy's in the way. There's that move. No. Where was I? Okay. That's the move that I want. Okay, 180 degrees. Out. Gyro. In. 180-degree movement. Okay, clockwise. Clockwise now. Okay. Now we have to do 180 degrees. There's a method to my madness. And 180 degrees. counterclockwise. Okay, clockwise, counterclockwise, out, gyro. Hands are starting to hurt. Not kidding. Tell me something good. Okay, it's really gonna be Miller time after this next move, so one move away from having this thing half done. It's last cell. Okay, we gotta go clockwise. We gotta go out, gyro, in, a clockwise motion, and then in, gyro, out. Yellow. We got a non-parity case. Okay. Let's check out some algorithms. Okay, so orange, white, red, yellow. Red, yellow. Is it this case? No, but is it this case? Yes. It's case number 3. Red, white, red, yellow, red, yellow, red, white, red, yellow. That's case number 3. So we should be able to do these moves. Okay. Okay, we're going to start with R. We can't do the moves normally. We have to do them all with gyros. Each one of these is a gyro. So 1, 2, 3, 4, 5, 6, 7. We're going to have 14 gyros to accomplish OLL. 14 gyros and 7 moves. And they're all R and U, thankfully. All right, let's start with R. That was R. Okay, U. Oh, no, I forgot to go in. U. R prime. R prime. Okay. Out. Gyro. That's R prime. U prime. Counterclockwise. In. Gyro. Out. And undo the U move. U prime. You know what? I got my algorithms mixed up. There is no U prime on this thing. I think I was doing algorithm 6 instead of algorithm 3. So, you know what? Okay, we're back to solving the first layer. This is what happens. First real mistake on the solve. All right. So we gotta go clockwise, gotta go counterclockwise. We're doing red, white now. Out, gyro. In. We said counterclockwise, I think. Okay. In, gyro. Out. Okay. Does that put that in a favorable position? Yes, it does. So we want to go clockwise. Clockwise. Gyro. counterclockwise. White. Okay, I see. Okay, clockwise. So counterclockwise. Out, gyro. In. Counterclockwise. In, gyro. Out. Okay. Counterclockwise. Okay, counterclockwise. Out. Okay, clockwise, and then we're done. Not with the whole puzzle. Not yet. Now, okay. Out. Gyro. In. Last 180-degree move. Not sure why it was necessary. We're not sure why it was necessary, but okay. So we're back to where we were, which is OLL on the last cell. If we solve perfectly, we were 2 algorithms away from being done. It's an hour and 54 minutes into the solve. Okay. Okay. May 11th. First 4 hours of May 11th. All right, I need a quick break. Okay. So we have an OLL case, which is on this diagram 1, 2, 3, 4, 5, 6. It's number 6. Okay, let's make sure we follow this really carefully. Okay, doing 6 very carefully. Starting with R. Out. Okay, that's R. U. Out. Clockwise move. Now, R prime. I think we put that back. Did we put that U back? I think we did. Or we're gonna have to go with it because I can't remember. So if we didn't put the U back, we're R prime. Ouch. Okay, U prime. U prime. Okay. Out. Gyro. In. Clockwise. In. Gyro. Out. U prime. Oh, boy. I don't know what I did wrong, if anything. Okay, but I gotta do this again. So R, okay. Out, gyro. In. That's R. Then U. Out. U. That's U. Okay. Now R. Out. It's actually R prime. In. Okay. Now U prime. Out. In. U prime. That was U prime. Okay, now R prime. R prime. F move. F move, and now an R move. Okay, ready to go counterclockwise. I guess this is F prime. Oh boy. Out, gyro. In, gyro. Out. Wow. We end up with a single twisted. I don't know what to do with this. Parity condition. Parity condition. Oh, they spawn with each other. Well, got the thing solved, folks, but it's a parity condition. The single 180-degree move. Now, I have an algorithm for a parity condition somewhere in my collection of algorithms. I don't happen to have parity condition algorithm with me. Excuse me for a second. I have it on my phone, I think. That's a problem when I'm filming on my phone. What's the parity condition algorithm? I can't find it here or. Okay, we're gonna wing it on this. Now, if we want to avoid the parity condition, we have to do it this way. Let's see if that avoids it. No, it doesn't. Not on purple. This avoid it. No, it just switched it to the other face. Okay. I can't find my critical different algorithm. Let's see if this actually does it. No. Well, folks, all right, let's not get too far off the beaten path. I already claimed this wasn't going to be a perfect solve. And I'm true to my word here. Okay. So we got to do another gyro, 180 degree move. And then another gyro. Okay, so I am going to cheat. I know there's an algorithm to deal with this situation that's able to be performed on a 5D cube. I can't find the algorithm. It's maybe 10 moves. It's on my phone, and I'm filming on my phone. I could execute the moves. I mean, not easily, but I have the capability to solve this. I can't find the algorithm written down anywhere. So I am going to cheat. This is the only cheat move in this whole solution, which went really well. And I'm going to do this, knowing that it's possible to do on the 5D cube. And I just can't find the moves. I'm sorry. If the heavens above wanted me to do this without cheating, then I would have been able to find that parity condition move, or I wouldn't have hit the parity condition. Anyway, 180 degree in a single twist is a perfectly valid 4x2 to the 4 position. And it's actually roughly 50% chance that it comes up. So, all right, enough of that jibber jabber. And we're now going to do my best to solve the rest without any further cheating. I mean, I cheated, yes. Okay, so white. Okay. Okay. So the last step Okay. So I have an algorithm that rotates the bottom right 2 by 2 by 2 90 degrees on the x-axis counterclockwise. This is the y-axis. Okay. We need 180 degrees about the y-axis. So we need to put the y-axis on the x-axis. Then perform this algorithm. Okay. Okay, now we need to do a left gyro. Next move on left. Right gyro. Left gyro. Left gyro. Okay. Okay. Let's see what that bought us. It's not solved yet. It's 2 minutes, 2 hours and 20 minutes into the solve. Rotate right tesseract 180 degrees on z-axis. I have instructions for how to deal with this. Left, it's the furthest I've ever gotten. Left gyro. Let's move on left tesseract. Right gyro. Repeat step 3. Next move on right tesseract. Okay, and then a left gyro. Okay. Okay. So, okay. Right gyro. Z-axis, left gyro. Come back in the middle window. Next move on left tesseract. Okay, and then a right gyro. Middle at the top. Top back in the middle, one done. Right gyro, repeat step 3. Okay. Next move on right tesseract. Okay, that looks correct. Okay, now for a left gyro. Is it solved? No. It's not solved. We haven't solved it yet. It's 2 hours and 26 minutes into this thing. Let's see what we need to do. We need to do. Okay. X move on left, that's correct. Right gyro. Repeat step 3. X move on right tesseract. Left gyro. Okay. 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 We're not solved yet. Is this where we want to be? Counterclockwise. X move on left tesseract. Right gyro. Repeat step 3. X move on right tesseract. Left gyro. Top back in the middle when done. Repeat step 1. Right tesseract 180 degrees on x-axis. What does this accomplish? Okay. You know what? I'm starting to think this actually is not, this is not a valid position of this puzzle. Not from a there's no set of moves doing this technique that I'm doing. There's no set of moves that would set this correctly. I don't think. Is that possible? Okay. No, there has to be. All right. I'm gonna need to take a short break. This is crazy. I've seen other videos of people solving the same puzzle and getting hung up at this step and doing enormously complicated things to get past it. I have a algorithm that will rotate 1 2x2x2. I'm taking a short break. This is crazy. Okay. Okay. I'm back. So we put, let's just see, yeah. Okay, so we need to do this algorithm correctly twice, and then we'll be solved. Unfortunately, it only does 90 degrees at a time. I don't have a way to do 180. This isn't like that other gyro thing. This is an old school set of moves I had from way back in the day for how to solve doing one 2x2x2 move at a time, which is not really possible. We're so close, I want to get it right. So, okay. Right gyro. Gyro. Next move on left tesseract. Right gyro. Repeat step 3. Next move on right tesseract. Now I happen to know that's not correct, so we're going to do another next move on the right tesseract. This is crazy. Okay, so the step I was at was X move on right tesseract. And we got stickers coming off. Left gyro. Repeat step 1. Okay, let's just see what that got us. Okay. We need to do, let me just see something. If I move this, okay, so we're 180 degrees away. We're one single 2x2x2 move away if I do it correctly. I want to come below 3 hours, just like my other solve. Okay. Z-axis move. We needed to be the Z-axis to be the X-axis. Okay. All right. Now, right gyro. Right. Thought back in the middle. Okay, right tesseract. 180 degrees on Z-axis. Left gyro. X move on left tesseract. Right gyro. Thought back in the middle, went on. Right gyro. Repeat step 3. Okay. Left gyro. Left gyro. Left gyro. Stop. Now back in the middle when done. Repeat step 1. Repeat step 1. Alright, so this part didn't work out so well. That's okay. Let's see if this... Okay. One moment. Okay. I've solved the cube, folks. It's now back to its original state, maybe rotated, but it's got all greens here, all blues here. We got the black stickers, silver stickers done correctly. Got purples on the outside and whites on the outside, and got pinks on the inside and that way, and yellows on the inside on this axis. And we've solved the cube. Now, we had lucky parity, so we had one cheat, but it's something that I just couldn't find the algorithm for. I have it written down somewhere. I think it's on my phone. What I've been doing is looking it up on my phone. Unfortunately, I'm recording on my phone, so yes. I did a 180 degree end cap twist. Not the correct way. I just twisted it. It's a valid position. I just didn't have the algorithm to deal with it. It's like 8 to 10 move algorithm. I couldn't find it. Other than that, this was 100% valid, no cheating. And I don't think I had any mistakes. Well, I had a few things I did wrong, but I don't think I had any mistakes in terms of canonical moves. I think all my moves were canonical. There you have it, folks. Let's stop the timer. This was 2 hours and 45 minutes. If you watch this whole thing, thank you for watching. I'll see you next time.